Hi, everyone, and welcome to today's webinar organised by JetBrains. So I'm Jodie Birchall, and I'm the Data Science Developer Advocate, and I'll be your host today. So the topic for today's webinar is one I'm super excited about. It's speech-to-image generation in Jina, and it's being presented by Alaeddine Abdessalem, a software developer at Jina AI. So Jina is a really cool company right here in my hometown of Berlin, and I'm really thrilled to have Alaeddine here as my guest today. So welcome.
Hi, everyone, and thanks for joining this webinar.
Yeah, so you actually just moved to Berlin this weekend, right?
Yeah, exactly. I came last Friday, and I was a bit shocked with the change in weather, actually.
Yeah, we were talking about it just before the webinar, and the exact same thing happened to me. So Alaeddine moved from Tunisia, and you were saying it was like 20 degrees when you left, right?
Yeah, exactly.
Yeah. And I moved from Melbourne in November, pretty much the same time of year, and it was 38 degrees, I think, when I left, and about the same temperature when I arrived. So nice to have snow, but maybe a little bit of a shock. Cool. So let's get back to talking about Jina. So Jina AI solves a problem that I think a lot of us struggle with in the data science and machine learning space, which is how to go from proof of concept, which, is sort of something that you tend to have on your local machine, maybe in notebooks, and then turning that into a productionized application. So Alaeddine, would you mind explaining a little bit about the company and how you help people do this?
Mm-hmm. Yeah, so Jina AI offers an MLOps platform for multimodal AI. Basically, we help you develop multimodal AI applications, but not just locally, but we help you move from local to the cloud. And we try to support you by offering scalability features, observability, and cloud nativeness.
And I think like all of these components are super essential. And I think putting them together yourself can be really difficult and time consuming. So we're going to talk a little bit more about how Jina does that later. But I, for one, find it really exciting having this platform that can just sort of do that for you out of the box. So the demonstration as well, you're not just giving us a, boring demonstration. It's a really exciting one as well. So like many in the audience, I think I've been really fascinated by the incredible models coming out this year. And in particular, it's been an absolutely massive year for image generation algorithms. And Stable Diffusion, I think, like in all the tussles about which one was the most popular, it's really come out as like one of the winners. And I think in particular, it creates really beautiful sort of artwork-like images. So there may be some in the audience who are not familiar with Stable Diffusion. Alaeddine, would you mind giving us an overview of what it does?
Yes. So exactly as you said, this year we heard a lot of models that emerged recently, especially in the domain of creative AI. And from Gina side, we've been working on projects that involve creative AI, like Disco Art and DALI Flow when DALI appeared. And now we have Stable Diffusion. And basically all these models let you generate artworks from text prompt. And this domain is evolving faster now. And you can imagine like you can do a lot of things with this amazing technology.
Like I remember when DALI 2 was first released, it was just like you couldn't kind of go a day on Twitter without seeing something. I was so jealous. I signed up for the early release like pretty much straight away, and I think I had to wait 3 months to get it. And then around that time, Stable Diffusion started becoming available, and some of the other models. So the other algorithm we're going to be talking about today is maybe a little bit less well known. It's Whisper, and it's a very cool model. It came out in late September. And the whole kind of point of Whisper is speech to text transcription. And because of the amount and the type of data that was trained on, it's actually a lot more flexible than other algorithms of this type. So I was playing around with a demo of it. Hugging Face has an endpoint for this. If you are interested in that, you can go to the blog post that we wrote for this webinar. But basically, I was sort of trying it out with different languages. I'm no kind of multilingual person, Alaeddine is, and he'll be showing that later. But I was trying a little bit of simple German, and even with an Australian accent, it was doing fine with that. So it's pretty cool. So what has your experience been like with using Whisper?
Honestly, I think it's great. It's trained on multiple tasks, and the way it does translation is really amazing. I have tried it with Arabic and French, and obviously transcribing with English is super smooth. And now you can imagine, like, when you see your YouTube audio being transcribed into your favorite language. I think this now can be achieved better with Whisper, I guess.
Yeah, I saw there's a guy who does, like, he's sort of an AI researcher, and he was basically saying that he was using it to create captions automatically for his lectures as soon as he records them. And he said it's awesome because it obviously makes them a lot more accessible. So yeah, this sort of stuff is important in terms of accessibility as well. Okay, so you're going to show us today how we can chain together Whisper and StableDiffusion, and we're going to be able to create a pipeline to generate images straight from audio. And like we said, you're going to tell us how to take this into production using Jina. So before we get into this, maybe just give us an overview of how you're going to do it and like why we would even care about taking this step.
Yeah. So first of all, as I said, Jina is a MLOps platform for multimodal AI. So the first part is we handle the MLOps part, which means that we let you deploy your pipeline as a microservice so that you compose different executors, or let's say components, and chain them together. And you can, for example, scale individual components or manage your resources effectively. You can monitor what's happening inside your components, and you can enjoy all the cloud native features actually. And for the second part, which is handling multimodal AI. So we all know in this pipeline, we will handle audio data as well as text and image data. So you will see in this webinar how Jina is good with multimodal data, and we can leverage the relationships between multiple modalities using artificial intelligence.
It's it's super cool, and like you've given me like a demo, and I've also read through the docs. You'll see how easy this is. It's quite amazing. So I think everyone's pretty keen to get into this. We've got a lot to cover, so I'm going to stop blabbing on, and let's just kind of cover some admin and get into it. So I've noticed people have been a little shy in the chat so far. We do like to keep the webinars as conversational as possible. So if you do have any questions or issues during the webinar, please do let us know using the chat in YouTube, or if you're on Twitch, also let us know using that chat. So I'm going to be keeping an eye on this chat the whole time, and we're going to have a couple of pauses where Alaeddine's going to be able to answer your questions. So please don't wait for the end of the talk. Do let us know what you're thinking or any questions you have as we go. And then please also be aware the webinar is being recorded currently. So that recording is going to be available pretty much immediately after we finish on YouTube. So any points that you might want to say from the webinar, we're going to have quite a lot of interesting links that we're going to share. You'll be able to catch those in the recording pretty much straight afterwards. So as I said, I am going to stop talking now, and I'm going to let Alaeddine get into the exciting part, and he's going to show us what we can do with Whisper and StableDiffusion and Jina Cloud.
All right. So hi again. My name is Alaeddine Abdessalem. I come from Tunisia, and I'm a software engineer at Jina AI. So these are social links at Jina. Feel free to join our Slack channel. Feel free to scan these QR codes to check our two awesome projects, Dockeray and Jina. And actually today we will be using them to create this pipeline. Okay, so first of all, I will quickly introduce Jina. We are a top-tier AI company founded in 2020. with 50 members distributed across the globe and with $38 million raised recently. So in today's webinar, I will quickly talk about creative AI, stable diffusion, and Whisper, which will be using them in this pipeline, and how to deploy and create the pipeline using Jina. And actually, we're going to have a live demo and coding using PyCharm. So let's start with creative AI. Actually, it's a domain that emerged really well this year. And it started with DALL-E, first version of DALL-E being released in 2021 in January. And then also this year we had DALL-E 2, but it was released as a service. And then late August we have Stable Diffusion with a public release, and which ignited, let's say, more usage and more opportunities for creative AI. Yeah, so with creative AI, you can do a lot of awesome stuff. You can basically give it text prompt, and for example, Ocean Beach in Van Gogh style, and it will understand this and will draw with Van Gogh style. You can see, for example, this is one of the projects I mentioned, Disco Art. We created this at Jina, and you can see how a diffusion model iteratively creates an image. So let's first introduce stable diffusion. And in general, diffusion models are neural networks that are trained to predict noise applied on images and use this prediction to denoise images. So in a diffusion forward process, actually we try to add Gaussian noise to pixel images, and the model will try to learn this noising. And then in the backward process, during prediction, actually, the model will use this inference to denoise the image from a randomly generated image, and with the guidance of a text prompt until we end up with a realistic image. Stable diffusion is a diffusion model with a slight modification, actually, because, so of course it will, it is text guided, and like other diffusion models, it will use a frozen clip model. And so instead of performing diffusion on pixel space, it will perform this on a latent space. So and after diffusion process finishes and the image representation converges to a realistic image, it will convert this representation back to the pixel space using an image decoder. And this is how a diffusion process looks like in stable diffusion. And let's also introduce quickly Whisper. As we said, it's a general purpose speech recognition model trained on multiple tasks. And we will use it today. We will use it for English transcription and any to English translation. So we can, using Whisper and Stable Diffusion, we will generate images from speech, but actually any speech. We will do this in English, French, and Arabic. And so for today's solution, this is how we are going to chain these two models. And actually, in Jina, we wrap Whisper and Stable Diffusion into executors. So we have first the Whisper executor, which receives audio, turns it into text, and then chained with Stable Diffusion, which receives text and outputs images. Yeah, so let's learn about executors in Jina and how we create this pipeline system in Jina. So as we said, Jina lets you create a pipeline, or we call it flow in Jina, as a distributed microservices architecture. And to do this, we handle different layers of abstractions for you, starting from networking to data and runtimes, microservices, up until orchestration. And you as a developer, you only need to care about implementing your logic and how the components are tied together into flow. To define components, or let's say business logic, you need to implement executors. So executors are basic components that encapsulate this logic. All you need to do is inherit the executor class, and then you can implement your business logic inside the endpoints. So for example, this foo endpoint will add some text to your documents. And in Jina, every executor receives documents as input and exports documents as output. And document is another basic building block in Jina, and it is capable of representing multimodal data like audio, image, video, text, and whatever. Yeah, and with this executor, you can do many things like encoding or generating images and so on. And then after defining your executor, you can chain them together using a flow. So here you can like chain two executors, one after the other. And finally, you can serve your executors. And actually, the Jina flow is a protocol agnostic. You can deploy it using gRPC, HTTP, or WebSockets. And you can start sending data using our client libraries. And then this is how you run it, and you can expose your service to the internet. And with Jina, actually, you can leverage different features like replication, sharding, several protocols supported, orchestration, Docker containerization, and we also offer observability and cloud deployment. So now we are going to move to a demo, and let's try to code this project with Jina. And so you can actually scan this QR code to access a blog post about this project or open the following GitHub repository. And yeah, so let me open my PyCharm. So for today, I will be developing using PyCharm on a remote server because I need several GPUs, and I will show you today how to have several replicas of your executors and allocate resources efficiently. And so the first thing that we want to do today is to start with the Whisper executor. So first of all, we need to create a folder in our project, and let's start by installing some dependencies. And here I need Jina and Cloud. So let's go ahead. Okay. And actually, I have everything installed. Then once you have installed Jina, you can go into your executors folder, and you can use Jina CLI to create an executor. So I will write Jina hub new. So this command will help you bootstrap your executor code into a project. So I will call it Whisper executor. Now it will ask me what is the folder. I will just press enter. Do I need to proceed with advanced configuration? I will say yes. And first, it will ask me if I want a Docker file, what will be the template that I want to use. And since Whisper uses PyTorch, I will choose Torch GPU. Here it asks for a small description, so let's skip this. Also GitHub URL, let's skip this. And now we should have our executor file here. Okay, let's open executor.py. And here, actually, you see that we import executor from Jina, document array and requests, and we inherit the executor class. So first of all, since we are going to use Whisper, we need to install it. So I will add the dependency in requirements.txt. So let me add this quickly. Okay. And let's try to install the dependency. Okay. Right. Now, after doing this, let us define the initialization of our executor. So let's implement the constructor in Jina. So let's actually start by opening the GitHub page of Whisper so that we can understand how to use this model.
Oh, actually, would you mind just going back to that link where you had the QR code for the demo? So we just had someone in the comments asking for that, and I think they didn't quite grab it at the beginning.
Yeah, sure.
Thank you.
Okay. And I will wait a little bit and I will continue. All right. So I guess we're fine, right? I think you're muted, Judy.
Oh, goodness. Thank you. Was the person who was asking for the demo, would you mind confirming that you were able to get that? Just waiting.
Mm-hmm.
We haven't heard back, but all good. I think we can keep going, and I can grab that link if not.
Okay.
Awesome. Thanks.
So as we can see here, Whisper is available in different sizes and different versions. So in our implementation, let's take the model name into consideration. So let's go back to coding, and when you initialize your executor, you can define parameters. So I will define model name, and it's a string, and by default I will use the base model. Right. Let's just put args and keyword args, and let's do all right. Okay, so let's first of all import Whisper, and let's do self.model equals, I guess it's Whisper load model. And I need to do model name here. Maybe we can also add some logs. So let's say self.logger.info. All right. And let's say the model was loaded. All right. So this is how you can initialize your executor. And once we're done, we can start defining an endpoint that is exposed to the internet. So let's call transcribe. And as we said, documents are the input, and the documents will be returned. So, so what we should do is to loop over all of our documents. So let's say for doc in docs. And as we said, actually, documents can contain several modalities of data, and it can also contain tensors. It can contain image URIs or speech or audio URIs and so on. So let's try to pass this information to the model. I will say model output equals self.model.transcribe. And so we can either receive data from document as URI, or it can be also saved as a tensor. So if it's URI, your information should be a audio URI like base64 or so on. And if it's tensor, then it will be PyTorch or TensorFlow or NumPy array. And actually, to know more about this data structure, you can consult the documentation of Dockerarray. And it's basically Dockerarray is data structure for unstructured data. And it is, as I said, the basic building block in Jina. Okay, so the model receives a tensor as an input, and it can also receive a language. And we want to, since we want to support multiple languages, we need a way to specify the language that we are going to use in our speech. And therefore, we can include this in some doc information. So docs can have a tags field. So it's like a key value pair. And in this key value pair, we can include the language key value pair. So let's say, let's grab the language key. And if it's not available, let's say that by default, we want to transcribe to English. And with this model output, we should be able to grab the transcribed text, and we can put it in the documents. So we can do doc.text equals model output, and let's grab the text field. Right. It should be it. I guess our executor is ready. So I guess it makes sense now to continue with other components of the system. But however, as I said, Jina lets you build components and orchestrate and deploy components, executors, and actually, you can reuse components. You can reuse executors. So all of the executors are available at cloud.jina.ai. So you executors can have like different types. For example, encoders. We have the indexers that can search and index data. And we can also find the StableDiffusion executor. So it is this one. And we can directly reuse it in our pipeline. So this means we have Whisper and StableDiffusion ready. So I guess at this step, we are ready to just define our flow YAML. So I will create a flow YAML, and I will use it for local development. So I will call it flow local.yaml. And I will use a feature in PyCharm that lets you enable auto-completion on your YAML files. So basically, I need to define Jina like YAML mappings. So you go into JSON schema mappings in your PyCharm configurations, you give it a name, and you can input this link. And then you just need to define some file patterns here so that you enable autocomplete. You can find more about this feature on this webpage in Jina documentations. just go to docs.jina.ai and you should be able to find this page. Okay, so let's say that the autocomplete feature is enabled. Now we're ready to start typing. So first of all, the G-type field, this YAML is for flows. So let's put flow, and let's try to fix. So when we expose our flow to the internet, it will be available on a port. Let's try to fix it, and let's say that the port is 54322. Okay. Now we can start chaining our executors. So all you need to do is define the executors section. And actually, we can start with Whisper. So I will call the first executor Whisper. And I will use this executor inside Whisper executor. So actually, you need to put this config.yaml file, which defines which Python modules you are going to use and some other meta information. So I guess I can just do this in PyCharm. Yeah, path from root content, and I can just paste it like this. Okay. And since in our executor we defined the model name like this, we need to specify this parameter. And actually, the bigger is your Whisper model, the better is your translation and transcription. So I will use the medium one. It should take around 5 gigabytes. So let's say, let's override this parameter using the uses with argument. So let's say the name is medium. Okay. And since we want to have each executor operate on a separate GPU device, I need to tell CUDA to look at specific devices. So for the first executor, so actually we can do this with the CUDA visible devices environment variable, and I will tell it to just look at the first GPU device. So let's quickly check which devices we have on this machine, and you can clearly see we have three GPU devices. I will use the first one for Whisper, and the other two for two replicas of Stable Diffusion. Okay, so yeah, let's say that I will make all GPUs available to this executor, but this just means that it has access to this to these devices, but we tell CUDA to just look at the first one. Now we can define the second executor. I will call it diffusion, and now with the users parameter, we can just grab the name from Jina Hub. So let's go back to this to the executor page. So the description says that the Stable Diffusion executor uses Stable Diffusion model to generate images, and it will be using the diffusers library. It will need a Hugging Face authentication token, and yeah, input is documents with text, and output is images stored in document.ure. Let's check some of the arguments, and the Hugging Face token is called auth token. And basically, we can just grab the name of the executor and say that we will use this executor from Jina Hub, and this is the name. And let's try to override the auth token. So let's do uses with, and let's say auth token. And since I don't want you to see my Hugging Face token, I will try to provide it as an environment variable. So this is so this syntax is compatible with GitHub Actions syntax. This is how you define an environment variable in Jina. let's define a timeout for this executor. Actually, I don't want any timeout at all, so I will just put -1. And I will say that I want 2 replicas. And I will tell CUDA, actually. So we will tell CUDA to allocate the second GPU to the first replica of Stable Diffusion, and the third GPU to the second replica of Stable Diffusion. So we can use this syntax to implement this. Basically, it means like the first one, like in a round robin fashion, goes to the first replica, and the second GPU goes to the second replica. Okay, so I believe the the flow YAML is ready.
And just before you keep going, I'm just going to interrupt. So some of the audience may not be familiar with what a Hugging Face authentication token is, or what Hugging Face is. So do you want to just give a very quick description of that?
Yeah. So Hugging Face basically is a portal to download and use models. And basically, since you pull models from their backend, you need to have an account in Hugging Face, create a token, and for some models, you need to accept their terms of services. So yeah, just make sure to log in, create a token, and go to the Stable Diffusion model card and accept the terms of services. And I hope this answered your question.
Yeah, it's totally clear. And just as a little bit of a geek out, Hugging Face has so many models to play with. They have endpoints as well, so you don't need to use them in code. So yeah, if you're at all curious about ML stuff or AI, I would recommend going and having an explore. Anyway, back to you. Sorry.
Yeah. So so once we're done with defining our flow YAML, we can just run this. Actually, we can use the Jina CLI. So we can do Jina flow. Let's use the helper. And here it tells me to provide a path to a YAML file. Actually, since I want to use debugging in PyCharm, I will define a run configuration. So basically, all you need to do is provide a path to your Jina executable. Let's say we use the flow subcommand, and we need to provide the path to our YAML file, and you need to provide the working directory, and I also need to provide the Hugging Face token as an environment variable. So I will just add this in another screen, and I will submit. So 1 second. Okay.
In the meantime, at the end of this process, we're going to have an app where we can actually generate images. So if anyone is inspired to think of some things that we might be able to generate, maybe drop them in the chat.
Yeah. So I'm done with writing my run configuration. I would like to add a breakpoint actually in my executor so that everyone can see what's happening inside. And I will run my flow using the debugger. Okay, let's see. Okay, so it's downloading a few weights and some files. Yeah. Now it's downloading, I guess, Stable Diffusion. All right. Now, actually, our flow is is exposed. So now we need a user interface to use the service to generate audio and send it to the service and then receive images back. So actually I wrote a UI script that uses Grad.io, and Grad.io is like a framework to write user interfaces with Python. So I will just copy paste this code here, and I will try to explain it quickly. So I will call the file UI, and basically we define a main command. By default, the host is the one that the flow just exposed. So as you can see here, it's localhost 54322, and basically we define this function that converts speech to text. It receives audio as input and a drop down where you can select the language. And as output, it will show you two images and the transcribed text. And yeah, so we use Jina client to communicate with our flow, with our deployed flow. Actually, we start by creating a document and putting the audio URI inside of it. We load it into Tensor. Let's say we put the language into the tags and we send it to the flow. And once we send it, we try to load images and then return them as input, as output. And we also try to return the text as output. So once we have this UI file ready, we can actually do Python UI.py. Okay, I need to go back. Now I can write this. And let's wait a little bit. And now I'm running my UI script inside my server. And since it's inside the server, you usually need so it's not exposed to the internet. You usually either need to expose it by opening your firewall or do port forwarding with SSH with the terminal, you know. But luckily, PyCharm here detects that our application is running on this port, and it gives me the option to do port forwarding automatically. So I will click on it, and it should open a user interface for me. So this means that we can now try out the application. So I will go ahead and record a prompt, and let's see. So I will start with the English language, and let's see what will be the output. Okay. Spider-Man is swinging around New York. Okay. So let's see what Stable Diffusion will give to us. As I click submit, PyCharm will stop at the breakpoint. And actually, I can expand the documents that I have received. And basically, you can see here the tensor that contains the audio data. So let's step in. And yeah, let me step out. Okay, so we can see actually the model output. This is the text, and it says Spider-Man is swinging around New York. All right, so far this looks really good. So let's continue. And I guess now the documents are flowing inside the Stable Diffusion model, and Stable Diffusion is trying to compute and generate images for us. And I guess here it's finished, so we can actually see Spider-Man going and swinging. And yeah, we can also see the transcribed output. So I guess we can try this out with another language. Let me first disable the breakpoint, and let's try it in French maybe. And let's say Spider-Man fait une promenade à New York. All right. And we can go back to the logs here. And yeah, I guess stable diffusion is done. And we have another set of results. But here, okay, yeah. But here it's like for the output, what I said is like Spider-Man is making a tour. I didn't say he's swinging around New York.
He kind of looks like he's like being a tourist in New York, actually. Like the
Yeah,
second one.
because literally that's what I said. Yeah. Yeah, well, we can also try this in Arabic, I believe. الرجل العنكبوت يتجول في شوارع نيويورك. And let's submit. And yeah, now you should notice maybe okay, one of the limitations of New York of the model. Well, actually, I might have done a bug where it's like when I do transcription, I converted to Arabic, not to English, and of course, Stable Diffusion does not understand like Arabic. So let me quickly try to debug this. And okay, let's see. So in our executor, so we called transcribe. Okay, and just a second. Yeah. Okay. So I need so in Whisper, if you just say the language, specify the language, it will receive it will receive speech using that language, and it transcribe using that language. So what you should do is say that the task is translate. So this means that the input is speech in Arabic, and the output will be English.
So that means that Stable Diffusion understood French then?
Yeah, exactly.
Aha.
So maybe Stable Diffusion was trained on French, but certainly not Arabic. Yeah, well, it's good to know. Honestly, I always thought that Stable Diffusion does not understand French, but now we know it is maybe capable of understanding French, or maybe it captured Spider-Man and New York from the output text. So, anyways, let's wait a little bit.
While we're waiting, we did have a question. So is this demo entirely cloud native, i.e. with no need to install models locally? And how much does it cost to run in the cloud? And can I run it all locally using a Docker file?
Okay, I think this is a really great question. So far we started with the local development. And as I said, Jina supports you in your journey from local to production. And just in a couple of minutes, we'll see how to deploy this on the cloud with Jina Cloud. And exactly, we will use Docker containers so that you don't have to install anything and you don't have to manage anything. As per the cost, right now, Jina Cloud is on the free tier. So you can get GPUs for free. And I guess we're still introducing a premium tier soon.
It's a pretty good deal, to be honest. Like GPUs for free. Yeah.
Yeah, just go for it. Just go for it. Yeah. Okay, let's try again, and I hope now the bug is fixed. Spider-Man يتجول في شوارع نيويورك. Okay, let's submit. Let's wait a bit. Okay, now this time it worked. And so it's saying Spider-Man wanders in the streets of New York. Obviously, I said he's like having a tour, but our little Spider-Man is just wandering here.
He's having a bit of a photo shoot, actually.
Yeah, yeah.
Are we going to be doing any more prompts, or is this it? Are you going to show some more prompts at the end?
Yeah, maybe at the end once we deploy to G-Cloud,
Cool.
because we have just one extra step. We show you how to deploy this on the cloud.
All right, then I let you get on with it.
Okay. So the transition to the cloud, I believe it's smooth enough. So first, let's inspect our flow YAML. We are using this Whisper executor, in which we have developed, and this diffusion executor, which we have reused from Jina Hubble. And what you need to do actually is to make sure all of your executors are either Docker images or Docker executors that come from GinaHub. So in GinaHub, basically every executor comes in two formats. The first one is plain code, plain Python code, and the other format is Docker image, and Jina will spin the container for you. So let's, so first of all, this means we need to push our Whisper executor to GinaHub. Yeah, let me stop the UI first. So you need to go to executors, Whisper executor, and you can do Jina Hub push, and like you can push this to the cloud. But before you do this, you need to authenticate to Jina Cloud. So you can do Jina auth login, and okay, here since I'm already logged in, I need to use the -f flag. This will open this link for you, and you can use your Google account or GitHub or whatever to do the login. Anyways, so once you do Jina Hub push, your executor should show up in Jina Cloud, and I actually have done this before. So my executor appears like this. You should be able to find your executors in your Jina Cloud account under the executors section. Now I have StableDiffusion, which I created it like weeks before, and I have the Whisper executor. So we can click on the Whisper executor, and yeah, let's say I want to use it in production. I want to use gRPC. I want to use okay. All right. Let's say development in Python via Docker. So this is how you can pull it actually. So I will copy this URL, this link, and I will try to put it in my flow YAML. So before we start, I will just rename the file to flow.yaml, and let me copy the link again. And yeah, in the user section, I will just put the link as it is. So make sure to use Docker here. And if you don't want to use an executor from the Jina Cloud, or you don't want to push your executor to Jina Cloud, then you need to provide a Docker container. I will remove this environment variable because it doesn't make sense in Jina Cloud. And besides that, I need to add some sections to that like tell Jina Cloud which resources do you need. So I will paste this section here. So basically, I'm telling it I want 1 GPU with 2 GB of memory. And to understand what are your GPU requirements, I highly advise you to check this GitHub link. Actually, it's this one, and you can see how many gigabytes each model needs. Okay, let's go back. Now for the diffusion. I just need to add the Docker keyword to my URL, and we should be good to go. So for this environment variable, you need to create a .in file like this one, and you need to put your Hugging Face token there, and that's how you can actually provide your secrets and environment variables to Jina Cloud securely. And of course, I will remove this environment variable. It doesn't make sense in Jina Cloud. And then I can paste the gcloud section for this executor. I will say I want one GPU per replica, and I want 16 gigabytes of GPU per replica. And I believe this is all. So all you need to do after this, so let's go back. And all you need to do is write Jina Cloud deploy, and you can say flow.yaml. Yeah, like this. And actually, you can read more about this Jina Cloud in our documentations. Go to docs.jina.ai, and you should find instructions at this page. Okay, so once you click on this, your flow will be submitted to Jina Cloud, and this should take around 10 minutes to download weights from StableDiffusion and assign GPU nodes to your application. And actually, I have done this before the webinar, and you should receive these logs when the deployment finishes. Your gateway will be exposed under this URL, and actually you can, so it's using gRPS, and so this uses TLS, and you can also access the dashboard to see metrics and have all the observability features of Jina. And I actually have the monitoring page open already. So let's try to send requests. So I will copy this link, my endpoint, and I can actually tell my UI script which host I want to use. So I can use this host parameter. Okay, sorry, I clicked. Okay, misclick. Okay, so I can do Python UI.py, and I can say host is this gRPCS link. And once you run it, let's wait a little bit. And again, PyCharm detects that I'm listening to this port. So I will activate port forwarding. And now I have a completely different deployment. So let's quickly give it a prompt. And
can I give you one?
Yeah, go ahead.
All right. So someone has requested a Hugging Face as a World Cup mascot.
Is a well?
A Hugging Face as a World Cup mascot.
Wild Cup mascot, is this what you said?
Yeah, World Cup, like the football World Cup.
Okay. Yeah, actually, I had another prompt about the World Cup. Maybe we can try it later.
Yeah.
Okay. Hugging Face as a World Cup mascot. Okay.
I have to admit, I tried this out on the endpoint as well, and this is so cute. Oh my god!
All right, so I guess StableDiffusion doesn't know much about Hugging Face, maybe. Although Hugging Face knows too much about StableDiffusion.
Yes.
Yeah,
it's not a mutual relationship.
Yeah, exactly. But this one looks a bit like Hugging Face, right?
Yeah. I have to say they're better than the results I was getting because I think I was using a smaller model, but these are much better.
Okay. Yeah, so my prompt was also related to the World Cup. So tomorrow Tunisia plays in the World Cup. And I can't stop imagining how it would look like if we win the World Cup. So let's see what Stable Diffusion thinks. Tunisia wins the World Cup in Qatar. Okay, let's let's submit.
You know, Australia's playing as well tomorrow, and our first game's against France. This happened to us last time as well, because we're not going to win that match.
Okay, well, it's close, a little bit close, yeah. It's really interesting because you see this item on this player. Actually, it's like traditional Tunisian clothes, so it's funny like to have this these features, and we can see the World Cup and so on.
That is so cute.
Yeah.
God, these models are so amazing. Like sometimes the results are like sometimes they're a bit demented, but sometimes they're so impressive.
Yeah, exactly. Maybe we can try other prompts.
Yeah, maybe maybe something Christmassy. Maybe we could say don't know, two teddy bears celebrating Christmas.
Two teddy bears celebrating Christmas. All right.
I have a feeling this one might work because it's a bit more artworky.
Actually, you can also tell the Stable Diffusion model which mode you want to use. So, for example, you can say digital illustration of Spider-Man. You can say I want it detailed, trending in ArtStation with vivid colors, and this you can expect such output actually. And I guess Stable Diffusion is better, or in general, diffusion models are better in this style of arts.
We had one more question. Oh, although he's on the
That's nice.
plate, I don't know. I don't know if he's celebrating so much, but that
Yeah,
one's cute. The second one.
yeah.
We had one final question, and then we might need to wrap things up. So, how good is Whisper at understanding iconic artist names?
Iconic artist names.
Yeah, I think famous names like David Bowie or Michael Jackson.
Well, I guess Whisper is good as at identifying names, persons, things that cannot be translated, and will keep them as it is. So, for example, Spider-Man, it identified it as Spider-Man in both languages, in French and in Arabic, and it kept it as it is. So I guess Whisper is really good at this. Yeah.
Yeah, and I think it depends how much training data you've got. So it didn't recognize my name when I was playing around with it, but because it tends to predict because it's based on the same sort of logic as GPT-3, it tends to predict things in a sequence. So like if you said like David, the idea that like Bowie would come next would be higher. Cool. So yeah, is that the end of the demo, or have we got anything else?
Yeah, just wanted to show you some of our monitoring and observability features. You can actually observe each of your pods. So we have diffusion and whisper. We have shards for the requests that are sent. I believe if I refresh, this will be more up to date. And you can also read logs and so on. Yeah, so I guess this should help you a lot in your journey from local to cloud, and you can have like close eye on what's happening inside your deployment.
Yeah, I think it would also it's like such a key part of any deployment, but I think it would also help you keep an eye on resources and stuff like that as well.
Yeah, exactly. So I believe this is all from my side. This is all about this demo.
This was amazing. Thank you so much. I really, really enjoyed this. I hope everyone in the audience did. Thank you so much for coming on. Thanks for preparing this. I think this is such an exciting thing to document because these are complex models, and with everything sort of already built into images, it's super simple to do this deployment. So yeah, thank you so much.
Yeah, thanks. Actually, as we can see, models nowadays have a lot of potential. You can do really amazing stuff with it, but there are quite some challenges. To be honest, I cannot run Stable Diffusion on my computer. I guess most people cannot. They don't have such resources. So you need to leverage the cloud to do this, and this is where Jina comes in.
Awesome. So would you mind if we actually get the slide up with the links, just so people can, yeah. So basically we've got a bunch of links here. So we've got obviously the PyCharm links. We've got some links if you want to follow Alaeddine's work specifically, but then also on the bottom right here, we've got a bunch of different links for Jina. So I think a bunch of you have already said you can't wait to try this out. So they're the best places to get started, or in the demo that we shared. And Alaeddine's also let me know if you have any questions that we weren't able to answer during the demo or that come up, please contact Jina on their Slack. So join the Slack. It's the best place to get all that answered. Yeah. Anything else from you, Alaeddine?
Yeah, I think thanks a lot for this opportunity. And I hope everyone enjoyed this webinar. And feel free to reach out to us and ask us questions.
Yeah. And just a final note from me is we're always looking for ways to make the webinars better. So please do reach out to us on Twitter if you would like to give us any feedback. We're going to send out an after webinar survey as well. So please do fill that in. We do read it and take it on board. We saw in the last webinar that you actually all requested an AI based demo. So we were happy to deliver that. And yeah, that's it for us today. So thank you again. I loved the demo. I'm going to go and try this myself. And yeah, enjoy the rest of your evening. So that's bye from us.
Thank you, everyone, and have a nice day.
Bye.